Welcome to Webinar Wednesday. We're excited to have Asimily sponsor today's presentation, which is eligible for 1 CE credit from the ACI. At the conclusion of this webinar, you will be able to access a link that will take you to a quick survey. You will be able to download your certificate once the survey is submitted. Before we begin today's webinar, I'd like to remind everyone that the first of our 3 HTM mixers takes place next month, August 19th and 20th, at the Omni Interlochen Hotel in Denver, Colorado. This event is supported by the Colorado Association of Biomedical Equipment Technicians. Join us for 2 days of networking, continuing education, and vendor engagement in a slightly modified, less crowded, and safer environment. Visit us at htmmixer.com for more information and to register for this event. Webinar Wednesday would like to thank our sponsor, Asimily. Asimily is a team with backgrounds in healthcare, security, machine learning, and analytics. The team has built and launched solutions for connected devices in healthcare in their previous roles. Asimily currently provides a medical device asset and cybersecurity management platform. Asimily solutions currently help providers understand all aspects of their inventory, discovers device relationships, does risk monitoring and mitigation, and finally provides an ability to prioritize patching and mitigation, providing alternatives to patching where available. For more information on today's sponsor, visit asimily.com. Okay, our presenters today are Shankar Somasundaram, CEO of Asimily, and Patrick Duncan, Integration Engineer from Methodist, Bonheur.
Thank you, Jamie. Hi, everyone. This is Shankar and Patrick here to talk about how we do management of a medical device at Methodist Bonheur as a real-world use case. So as a quick overview, in this session, we're going to talk about specifically inventory and cybersecurity management of medical devices at Methodist Bonheur. We'll talk about some of the challenges that were faced, including around vulnerability management, return on investment, and the collaboration and cooperation with IT teams. And then finally, Methodist will also talk about some of the future plans on how they plan to improve the medical device security posture and how they're keeping in track with the current industry trends. A quick overview about Asimily. Asimily is a venture-backed company. We are healthcare focused, and we are working with health systems across the country in managing medical and their IoT devices. We have people with a variety of different experiences across security companies, networking companies, healthcare organizations, and we have a strong set of people who are advising us and guiding us. And we integrate with a number of different systems, which include SIEM, CMMS, NACs, firewalls, vulnerability scanners, and others. So, Patrick, over to you about Methodist.
Thank you. Hi. Thank you for your time today. My name is Patrick Duncan, and I work in clinical engineering at Methodist Bonheur Healthcare in Memphis, Tennessee. We are a 6-hospital system with about 1,600 licensed beds, and by the end of the year, that should grow to 8 hospitals with about 2,400 beds. As you can see, we have about 40 biomed technicians, specialists, and imaging engineers. And I work for a department within clinical engineering called Clinical Technology Services, and we offer medical IT services, project management, medical device integration, and cybersecurity. So we have about 31,000 devices in our CMMS system, and almost all of those are serviced in-house. Next slide, please. So early on, we were just trying to identify all of our network devices. And I was working mainly off of spreadsheets that consist, it's pretty basic, IP addresses, maybe the model, manufacturer if I'm lucky, OS, maybe an AE title here and there. But it was far from complete. There was a lot of holes in my data, and it turned out that some of the IP addresses and operating systems that I had on my sheets had changed. So I was attempting to identify all of my unknown parameters. Again, operating system, device type, software versions, the basics. And I was trying to, as I'd find them, I try to locate that device in our CMMS system and then update anything I could. It's a very manual process. So after a while, we had a basic idea of our connected devices, but we really did not know how those devices functioned on the network. It's pretty clear from a security point of view that we needed more device specifications. We needed things like software versions, firmware, software bill of materials, ports and protocols used, and so on. And to find this information, I initially started with the manufacturer's technical documents. I relied a lot on the MDS2 documentation, and if it existed, our own installation documentation. But in some cases, to really get the security parameters I needed, you would need to use a packet analyzer such as Wireshark to manually map ports and protocols of any the device was using. And it was becoming pretty clear that a lot of the parameters were just not going to be available in a timely or efficient manner. So we, really had to start looking at another way to do this. Next slide, please. So we performed several time studies. At one point, we even hired a large vendor to come in and give us an estimate of what they would charge for us to gather the basic equipment information that I've been trying to get all along, and that was operating system, make, model, software versions, network information was very helpful, and so on. But being that it was a manual process, we were also working around the equipment availability. And we determined after some time that it would take about 6 engineers at least a year to get this information. But we still wouldn't have all the other analytics that we need, like equipment vulnerabilities and risks. So we decided that this really, a manual process, even though we knew it was going to be expensive, the cost was kind of intangible. So we decided we were going to have to look at some automated solutions. Next slide, please. So early on, I was working with our IT department. Most IT departments have very useful network discovery tools that will scan looking for endpoints. These use active scanning technologies, which I was not a fan about, so I wanted to do some testing in my lab. So I set up a small network. I had 4 Draeger physiological monitors hooked to simulators, and every night we would do a scan and then gradually overnight crank up the intensity. And we started off really gentle and then ended up with some really invasive scans. And one morning I came in and all my monitors were in an asystoly alarm, which was very concerning. And in the interest of, transparency, that was a very invasive scan. I don't know if you would ever really encounter that in the real world, but it could still happen, and it did change the values on the monitor. So at that point, we decided against any active scanning of medical devices. Shankar is going to talk more on this later, but I just wanted to point out that you really can't treat medical devices like the typical IT endpoints. So we looked at several products, and almost all of them were good tools. They each have unique features, but they all seemed like they were network discovery tools that were, would, by the way, work with medical equipment. And we wanted something that was really designed from the ground up to work with medical equipment. We had a lot of parameters that we're searching on for a product, but my main 2 were that it used passive scanning and that it incorporated the MDS2 document. Next slide, please. So we went with Asimily. We installed a collector in each of our hospitals, and all the data is sent to the cloud. I wanted to mention that all the PHI is dropped at the collector, and almost instantly, I had some intelligence, real actionable intelligence on what was happening on my network. I learned right away that I had over 7,500 medical devices that were connected. In other words, that's about 24% of my total equipment base. And surprisingly, 59% of my connected devices were wireless. But we're also getting a lot more information, like all the IT and cybersecurity parameters that are really needed. And I did find that the accuracy rate of the identified devices was above 99%. So we also share the Asimily portal with our IT department, and they use it for managing IoT and building devices. Can I get the next slide, please? So here's an example of a query builder. Last time I counted, there were 52 parameters that you can select from, so it's very configurable. There's 3 sections. The top is a little hard to read, but it's medical device parameters, so you can select things like manufacturer, model, device type, serial number, location, so on. The center are your IT parameters, things like IP, MAC address, operating system, VLAN, CMMS ID, your wireless parameters, things like that. The last section are your risk and impact and anomaly parameters. So you can get your risk, likelihood, and anomaly scores, your business impact, any recall information, things like that. So these would all be columns basically that you can have exported into a report, and you can report these out nicely into an Excel spreadsheet for further analysis or reporting. Click the next slide, please. Well, Shankar, actually, I'm going to turn this over. The next few slides are yours.
Yeah, no, thank you, Patrick. So basically, Patrick covered inventory management. So let's go to the next piece around vulnerability management. So like Patrick mentioned at the beginning, medical devices are not the same as IT devices. In the world of IT devices, you can have like a variety of different workstations and laptops, which you can effectively, just run an active scan, get the vulnerabilities. They probably have similar risks. They have similar levels of patch, and so that is the approach you take in IT. And then you would just patch them, right? You scan them, patch them, and they would have similar risks. They have similar outdated levels of operating system. Medical devices are very different. You cannot scan them, like Patrick mentioned. They can have a lot of adverse effects. Patrick has done some excellent studies on that. We have seen similar studies also done, and there are a lot of adverse effects on scanning medical devices. And the other interesting part about medical devices is not all devices have the same risk. You can have the same device, same manufacturer, same operating system, same model, but the risk could be different because there are a number of factors that affect the risk of a device in these environments. It depends on whether the device has a vulnerability which is exploitable for that device in that environment. And this could change from even across the same devices, like I mentioned, because what we have noticed is the same model, same manufacturer, same operating system, same version, sometimes it's configured slightly differently on the network. The clinical use could be slightly different. The way they're operating is different, and that could have impacts. The impacts could also be different, the way they are connected, how many of those you have for a given kind, the utilization, all of those, many different factors come in when you determine the impact. I already mentioned about the device being connected. The security capabilities are different. What you're putting in front of the device to secure the device, those could be different. And again, any other mitigating security controls that you choose to add. So Asimily takes into account all of these factors and a few more. And there are like a number of parameters here that comes as a combination of Asimily research, the way the device is configured, MDS tools, and a variety of other parameters. And then it combines all of them. And then it provides those vulnerabilities and devices which are high risk, high impact. And then finally, because you might not have a patch, in fact, you almost will never have a patch, Microsoft releases around 500 vulnerabilities on an average, few hundred vulnerabilities, around 500 a month. A manufacturer might be releasing like a couple of patches a month. So for most of these vulnerabilities, you will never really have a patch. So to mitigate the risk, Asimily also provides a workaround, which is outside of segmentation and blocking. So true network workarounds that can mitigate the exploit vector of that vulnerability without doing a patch. You can bring the risk down. So that's what we have done at Methodist as well. And this is one example of that from the scoring perspective. So here you see, on the portal we selected Philips Healthcare. Philips Healthcare as the manufacturer. We selected the device type as an ultrasound, the model as an i33, and the OS as XP. So they're exactly the same, even their versions are the same. But if you look carefully, for the piece marked in red, you have devices which have a risk score of 8, but you have also devices which have a risk score of 6, and they're exactly the same. And this goes back to my point, where even if you have the same manufacturer, device type, model, OS, serial number, not serial number, firmware version, everything, you still can have different risks for those devices because each device is independent in the network, and even if they share the same parameters, there is some differences in the way they're connected, configured, or used to change the risk scores. And that is very unique to healthcare, which we have been able to capture, and Methodist has been able to use like other health systems. And this is an example of a workaround, like I had mentioned. So in this workaround, we actually shown a Windows XP vulnerability, which is there. And we say, okay, there's a Windows XP vulnerability. Now, clearly, Windows XP is a very old operating system. You won't be able to patch it. And we find Windows XP in every health system. It's not surprising at all. It's there in every health system. And, some health systems have a lot of them. Some have a few. So here we have a Windows XP operating system. And here we have a Windows XP operating system. And so here we are saying, okay, you cannot do a patch. So here we are saying, what is the exploit vector? And this is like the MITRE attack framework, where this is like a drive-by download. And we said, okay, that is the kind of attack you want to have. So device being used for web browsing, it's going to cause a drive-by download as per the MITRE attack framework. So we are saying the exploit vector is, hey, you have an ultrasound. You don't really need to be browsing an Amazon.com on an ultrasound. So you can stop that, and that could mitigate that exploit vector path for this Windows XP kernel vulnerability. Or you can actually block the download of link and PIF files, which effectively are used by the attackers for this particular vulnerability to exploit the vulnerability in the network. So this is a classic example. You have an XP vulnerability, it's in the kernel, and you're not going to be able to just go patch it. There's no patch. You can't just go install a Microsoft patch. It's going to invalidate your warranty. So you can just block it from browsing. That is the exploit vector for this particular vulnerability. Or we have gone even granular and said, if you block the download of link and PIF files, you can pretty much mitigate the risk as well, because that's what's being used by the attackers to exploit the vulnerability, right? And so this changes. These kind of exploit vector research is being done on a vulnerability per vulnerability basis. So we have a repository of hundreds and thousands of vulnerabilities, and they give you clear recommendations. And what is amazing about this is you can group all the recommendations, and you can take certain kinds of common actions on the network, which effectively do not impact your clinical use, and for the subset of high risk, high impact, can mitigate the risk and save you a ton of costs around decommissioning, so you don't have to decommission the device while effectively managing your risk.
So we start considering medical device cybersecurity before we even purchase the equipment. Before any device can be connected to our network, it has to pass an IT security and risk assessment. And they will evaluate both the vendor and the product. They ask questions like, does PHI leave the network? Does it leave the country? Is the data encrypted? What type of encryption do they use? Does the device support any kind of federated identity or dual mode authentication? Things like that. As far as prioritization, Asimily does have a very nice chart on the dashboard screen that identifies likelihood and impact by device type. And I really use this as my mitigation roadmap. We do have our own WS server in clinical engineering, and I use it to apply security patches to, but I only apply patches as specified by the manufacturer and the MDS2 document. And I wanted to point out that as far as security patches go, some manufacturers really don't care, and others are very particular, and they typically will have a portal which will tell you which patches are allowed for which products. So you might want to look into that. Workarounds, for example, there was a quick one. There was recently a problem with Microsoft Remote Desktop RDP, and they suggested turning it off. Well, in some cases, we couldn't. So we just set everything to use network level authentication. And but what I wanted to get at was Asimily was very helpful in finding those devices that needed to have that service turned off. I very often use the Asimily workarounds that are recommended in the product. Another example of a workaround, we have a few older legacy devices that are not patchable. For example, I have an MR system that has a Windows XP controller. It's not upgradable, it's not patchable, and it would cost a few $1,000,000 to replace, and it works fine. So until we can afford to replace it, I essentially hide these devices behind a small firewall appliance that is set for source natting. We typically turn off all services that are not needed, block ICMP, and it is just hidden on the network. Next slide, please. So I check daily for anomalies. I look for any unexpected connections like FTP, RDP, SMB, and so on. I try to investigate every external connection, and if it isn't necessary, we take steps to turn that off. A quick example, we had some monitors that were set up in an ad hoc environment for some testing, and one of the engineers put an address of 1.255.255.255 in it for a printer address, and that device eventually worked its way into production, and they failed to clear out that value. And sure enough, one day I'm seeing like I have a device that's reaching out to Korea, and it turns out that's a valid address in Korea. So things like that, where I mean our firewall blocked it, but still things like that are good to know. So anyway, I monitor all of these and record them, and then I work with biomed or our imaging engineers to get all these connection attempts blocked. And again, we also share the Asimily interface with IT for the management of IoT and various building devices. One other example of this is I was noticing that I was having a lot of FTP attempts on several different devices, but it was always using the same username and password. It was very, very suspicious looking. And I worked with Asimily on this, and they added some forensic analysis tools that actually allowed me to pinpoint the source of these. And it turns out it was our IT department's Rapid7 scanner or server. Basically, these devices were being scanned. So we worked with IT to get them added to the exclusion list, and that came to an end. But I just wanted to point out that there should be some cooperation with your IT department on things like this. Next slide, please. Or actually, Shankar, this one's yours.
Yes. So this is mine. So thanks, Patrick, again. So we are talking about anomaly and forensic analysis, and this is just an example, a snapshot from the Asimily portal. And Patrick spoke about an example where he found a number of FTP attempts across a number of devices. Turns out it was a scanner. This is a slightly different use case where there are these devices which are effectively using default username passwords, like the G device shown here, and there are a couple of others. And effectively for these kind of devices, you want to go contact the manufacturer, because from a vulnerability perspective, even though we classify it as an anomaly, this one could be classified as a 0-day attack or like a vulnerability with a default username password, however you see it. And so you want to be very careful here, because you want to make sure you change the username password with the manufacturer's permission, or you effectively have some actions and some access controls. So you control access to these devices, which otherwise could pose your own risk. And Patrick gave a couple of examples of, anomalies. This is another example of an anomaly. So there are many, many different such categories of anomalies that Asimily discovers, categorizes, and then shows, which the health system can then use to investigate, to understand the anomaly, and then through the forensic analysis that we have added and we have enhanced, understand the root cause of the anomaly as well. So next slide, policy management, Patrick.
All right, thank you. So we can create policies to track all kinds of events and then receive notifications if these events occur. I have policies set to look for new Windows XP devices on the network, and also, for example, when a mobile device is connected to an imaging device. One policy I hope to set soon would be, it would tell me if a wireless device has left the facility. What we plan to do is try to identify the access points near all of our exits, and then if a device connects to one of those APs, let me know. Next slide, please. So this is an example of the policy management interface, and it just really takes a few minutes just to create a policy. Next slide, please. So we have done taken a lot of steps, but the first thing we did was make sure that we had a secured wireless network that was for medical equipment only. And we also ensured that it's not internet facing. We avoid Bluetooth accessories whenever possible. And like I said, during procurement, if there's an option, let's say between a Bluetooth accessory and hardwired, we'll take the hardwired. I use Asimily to identify risk and impact of devices. And like we've mentioned before, we'll use firewalls for high risk, high impact legacy devices that can't be patched or otherwise mitigated. Here lately, we began to use USB plugs to physically block open and unused USB ports, just trying to discourage people from plugging things in that shouldn't be. We have a policy that if a device can use Active Directory, we try to use it to manage logins. But I do want to mention that if you do use AD, you need to look out for inherited group policies. Sometimes GPOs are pushed down that you wouldn't expect, like screensavers or auto locking features, power saving modes, things like that. You don't want a camera shutting off in the middle of surgery or going into a screensaver. So you get your own AD location and break all the inheritance going to it. And we treat the MDS2 as the rule of law. So when it comes to applying typical IT security strategies to medical devices, if the MDS2 document says we can patch for security or malware or AV, we do so. And if it doesn't, we don't. We take other steps to protect the device. Next slide, please. So with automation, we are doing all this at a fraction of the cost what it would have been compared to manual. Plus, we're getting all the information that there's no way we'd have got that manually. And when we combine this with the services that Asimily provides, you know, the vulnerability and exploit analysis, risk prioritization, impact analysis, remediation, things like that, it's just hard to quantify the savings. Next slide, please. So we're getting close to going live with our CMMS integration, which, by the way, we use AIMS for our CMMS system. And this will be very helpful for trackability. Work orders will be generated in AIMS for any detected anomaly or vulnerability. And the network parameters that were detected by Asimily will also be pushed into AIMS. We're also looking at integration of Asimily with our Cisco ICE products for segmentation and access control lists. And we're also looking at some interesting modules. There's a imaging scan monitoring and dose monitoring reporting for our imaging devices that should be coming along soon. And basically, we're trying to use Asimily as like a single unified plane to manage all of our medical device cybersecurity needs. And again, we're also looking at procurement risk analysis by using Asimily to evaluate products in my lab before we even purchase them. Anyway, I'm going to hand it over to Shankar. I wanted to thank everybody for your time today.
Thank you, Patrick. So with that, we have concluded the presentation. We have covered a lot of things today. Please feel free to reach out to Patrick or me. I'm available at Shankar, my first name, at asimily.com. And Patrick is available at patrick.duncan, the first name dot last name, at mlh.org. mlh.org, right, Patrick? So,
that's right.
Right. So patrick.duncan at mlh.org, and then Shankar at asimily.com. So feel free to reach out to us, and happy to answer any questions that might not have been answered in today's presentation. Thank you, and talk to you soon.
Thank you, Shankar and Patrick. A quick reminder for all of the attendees today, to obtain your certificate for 1 CE credit from the ACI, please remember to click the link located below this webinar title to complete today's survey. Once you complete that survey, you'll be able to download your certificate from your desktop, laptop, or mobile device. If you have any questions, you can reach us at webinars@mdpublishing.com. For more information about our upcoming webinars, be sure to visit webinarwednesday.live.